Hi, my name is KermadKareem, and this is video evidence for my AQA A-Level Computer Science Non-Examined Assessment Project. The title of my project is Comparing Pathfinding Algorithms, and I am now going to demonstrate the key features of my program. To create a grid, I will choose some values to input into the rows and columns fields. I'm going to create a 10 by 10 grid with 10 rows and 10 columns. I'm going to set the grid line thickness to 1 and the brush size to 1. To create the grids, I press the Update Grid button in the menu. By left-clicking on the grid, I am able to create static obstacles above cells. I can right-click on the cells in the grid to delete these obstacles. To clear the grid and start over again, I can press on the Update Grid button. I am now going to increase the brush size to 2. Increasing the brush size will increase the number of static obstacles that can be created on a single mouse click, as shown. I can also delete these obstacles with the same brush size. I am now going to change the brush size back to 1. To move the start and end cells for the path, I can drag them across the grids. Alternatively, I can use the input fields from the menu to change the coordinates of these path cells. I am unable to drag these cells outside the grids. And I am unable to drag these cells above obstacle layers. I cannot drag these cells above each other either. To view the performance statistics, I can click on the Update Performance Statistics button at the bottom left of the menu. The performance statistics have not been updated recently, as I have not run the simulation yet. I can go back to the main screen by clicking on the Return button. I am now going to demonstrate the pathfinding algorithms and simulation tools. By clicking on the Play button, I am running the simulation in real time. I can stop the simulation by clicking on the Stop button. By toggling diagonal movement in the menu, I can run the algorithms with diagonal movement enabled in the grid. The drop-down menu can be changed the pathfinding algorithm I want to use. I am now going to be using Dijkstra's algorithm. As the algorithm is run, the performance statistics are getting constantly updated. The graph shows the minimum, maximum, and average time, as well as path length, although these values are constant. I am now going to create a larger grid to use. can create a moving obstacle by clicking on the Create button. I can click and drag to resize the moving obstacle, and then release my mouse to create it. I can select and deselect the moving obstacle by clicking above it or elsewhere on the grid. I'm going to change the speed of the obstacle, and I can add some waypoints to the grid by left clicking. I can delete these waypoints by right clicking. I cannot delete the starting waypoint. The moving obstacle stops at the final waypoint because backtracking was disabled. If I enable backtracking, the obstacle will loop and will continue to do this until I stop the simulation. I can press the fast forward button to run the simulation in fast forward. When running the simulation in fast forwards, the program will collect a lot of data on the run's time and length. I can delete a moving obstacle by selecting it and then right clicking. I can create many moving obstacles, and all of these moving obstacles are independent of each other. I am now going to create a 1000 by 1000 grids and use the A* binary heap algorithm to demonstrate the efficiency. The average time is currently 0.6 milliseconds. A nice animation of the plot can be shown by creating a moving obstacle in the grids. The way the graph changes is really nice. I can paint static obstacles on a 1000 by 1000 grid relatively smoothly too. performance statistics can be very useful, especially when analysing the graph. That concludes my video evidence. Thank you for watching.